Welcome back to the lecture series in Python. In this video, we are going to learn about various operators in Python. In any programming language, operators play a major role. Without operators, we cannot perform any task. So now let us see what is an operator and classification of various operators in Python. So operator is generally a symbol and it performs a particular operation between the operands. And these operands can be either constants or otherwise they can be variables. And in Python, we can classify the collection of operator into various categories. First comes arithmetic operators, then comparison operators, logical operators, bitwise operators, membership operators, identity operators, and then assignment operators. So in this video, we are going to explore in detail about all these operators. First, let us focus on arithmetic operators. So arithmetic operators generally perform basic arithmetic operations like addition, subtraction, multiplication, and division. So in Python, we have a special division called as floor division. And also we have operator for performing exponent operation. So now we will see all these operators in detail with examples. So first I have two variables a and b, and they are initialized with integer values 10 and then 3 respectively. And to perform addition between these two operands, I'm going to use the plus operator. When I print the answer, it is simply going to add 10 and 3 and the answer will be printed as 13. And then to perform subtraction, we are using the minus operator. So it is going to print 10 minus 3, that is 7. And for multiplication, we are going to use asterisk. So it will multiply 10 and 3 and the answer will be printed as 30. Now comes an important difference in Python. We have the divide operator. So in case of Python, when we use the divide operator, irrespective of the data type of the operands, it is going to perform float division. So what is the meaning of this? Here, A is 10 and B is 3. When I divide 10 by 3, I am going to get the answer as 3.333, etc. Up to certain precision, it will be printing the values. In case of C programming, if both the operands are integer, when we perform division, we will be getting the result as integer only. But it is not the case in Python. Even though when both the operands are integer, when we use normal division, it is going to give the answer in float only. And suppose if I want the answer as integer, I want to truncate the fractional part. So in that case, in Python, we have a special division called as float division, which is represented by double slash symbol. When I do float division, here I'm doing the float division. So it is going to now print only the whole part. It will be truncating the fractional part. So I'll be getting now, instead of 3.333, I'll be getting only the whole number, that is 3. This is the difference between float division and then float division in Python. In other programming languages, we don't have like this. In Python, we have a special case like this. And similar to other languages, we have modulus operator. So that is percentage. It is going to give reminder after the division is performed. So in this case, when I try to divide 10 by 3, because here I'm using a percentage b, that means I'm going to divide 10 by 3. I have to see what is the remainder of that. So in that case, the remainder will be 1. So it is printing 1 as the answer. We can even perform the power, that is nothing but exponentiation, by means of double asterisk symbol. So this is now going to perform a raised to the power b. That is nothing but 10 raised to the power 3, it is 1000. So these are all various arithmetic operators in Python. Hope it is clear. So main thing is, what is the difference between float division and then float division? Now let us see the next category of operators, that is comparison operator. So comparison operators are also called as relational operators, and they are mainly used to compare the value of the operands. And based upon the value of the comparison, they will return either true value or otherwise false. So they are generally performing conditional checking. And the answer of the condition is a Boolean value. It can be either true or otherwise false. And in Python, we have the following comparison operators. They are equal to and not equal to, less than, greater than, less than or equal to, greater than or equal to. Now let us see all these things with an example. So I am again taking A is equal to 10 and B equal to 3. When I check A double equal B, it is going to check whether A and B are having the same value. If they are having the same value, it will return true, otherwise false. So in this case, A is 10, B is 3. They are not having the same value, so it will be returning false. And when I check A not equal to B, it will check whether A and B are not equal. If that condition is true, it will return true. So in this case, A is 10, B is 3. They are not equal. So condition is true. So answer will be printed as true. And the third is going to check whether A is less than B. If that condition is true, true will be returned. So here 10 is not less than 3. So it is false. So when I print, I am getting false here. And the fourth one is A greater than B. When A is greater than B, we will be getting true as the answer. So in this case, A is greater than B, true. So I am getting true as the answer. And next is less than or equal to. So here I am checking whether 10 is less than or equal to A. A is 10. So 10 is equal to 10. So I am getting true and that is printed. And the last one is A greater than or equal to B. So in this case, 10 is greater than or equal to 3. So again, true will be printed. And coming to the next category, it is logical operators. Logical operators are generally used to combine conditional statements. They are mainly used in case of decision making and then looping statements. And we have three basic logical operators in Python. So one is AND operator, next one is OR operator, and the third one is logical NOT. And all these logical operators will return either true or otherwise false. And in case of logical operators, we have to follow the logical table. That is the truth table of the logic gates. So in case of AND, it is going to check two conditional statements. When both the statements are true, this is going to return true. And if any one of the statement is false, it will be returning false. And then the second operator is OR operator. It is going to return true if one of the statements is true. And in the case of NOT, it is simply going to negate the result. If your original output is true, it will be returning false. If the original is false, it will be returning true. So let's see an example. So here I have two variables A and B. A is initialized with the Boolean value true and B is initialized with the Boolean value false. And I am printing now A and B. So in case of AND, the output will be true only when both the inputs are true. So here, one of the input is true and the other is false. So false will be printed as the output. And in the second case, I am performing OR operation between A and B. So in case of R, here, one of the input is true. Therefore, irrespective of the value of the other input, it will be printing me true as an output. So the second one is printing true as an answer. And the third one is not A. I am printing not A. A is true. So not A means it will be changing that to false. So that is now printed as an output. And now let us see how we can combine various conditions with the help of this. So here I'm going to initialize two variables CGPA with the value 9 and then number of arrear with the value 1. Now I want to check whether CGPA is greater than 7 and arrear is equal to 0. That means a company is coming for a placement. They are telling that the student should not have any backlog and the CGPA should be greater than 7. Then only they can appear for the first round. So in that case, we have to check both the conditions now. The first condition is CGPA should be greater than 7 and number of arrears should be equal to 0. When both these conditions are true, then only the student is eligible for the first round. So I am printing this. So in this case, the first condition CGPA greater than 7, it is true because 9 is greater than 7. Whereas the second condition arrear is equal to 0, it is false because the particular variable arrear is initialized with 1. So the output of this particular operation will be now false. So with the help of these logical operators, we can perform complex conditional checking. Next category of operators is bitwise operator. These operators are mainly used to perform bit by bit operations. So whatever operators we have seen so far, they are working on the entire data, that is either the numeric data, either in terms of integer, float, and so on. And in case of bitwise operators, they will perform operations on bit level. So these operators are listed below. So we have bitwise AND, bitwise OR, bitwise NOT, and then bitwise XOR. This is the caret symbol. And then bitwise right shift, then bitwise left shift. For bitwise right shift, we have to use two greater than symbols. And for bitwise left shift, we have to use two less than symbols. Now let us see these things with an example. Now let us consider that we have two variables A and B. A is initialized with 5 and B is initialized with 6. Now, since we are going to work with bitwise operator, we are going to print the value, original value as a binary number because bitwise operators are working on binary data. So let us print the bits now. So for printing A and B in the binary format, I'm going to call the function bin because whatever values we are initializing here, they are decimal values. We need to convert them into binary. So I am converting A and B to the binary value with the help of bin function, and then I am printing it. Now let us see what is the binary value of A and B. A is now 5. So when I print the binary value, it will be printing me 0B101. 0B stands for it is a binary value. 101 is nothing but binary equivalent of 5. And similarly, when I print bin B, it is going to print the binary equivalent of 6. So binary equivalent of 6 is 110. Now let us perform binary operations one by one. First, we will perform binary AND operation, bitwise AND operation. So when I print A and B, so this is bitwise AND. In case of logical AND, we will be using the word A and D. Whereas when we use one ampersand symbol, that is bitwise AND. So when I perform bitwise AND between A and B, it is going to perform the operation bit by bit. So now let us consider the binary representation. So 101 is binary of A and 110 is binary of B. So we have to perform the operation on the corresponding bits of both the numbers. Now let us take the LSB. Here it is 1. The second number it is 0. So 1 and 0 is 0. And then in the second digit we have 0 here and in this 1. So again, one of the value is 0. So the output will be 0. And in the third digit, we have 1, 1. When both the inputs are 1, and will be printing 1 at the output. So we are getting 1 at the output. So now we are getting 100 at the output. This is binary. So when I convert that into decimal, I'll be getting the answer as 4. So here this statement, line number 9, print A and B is going to print 4 as a output, because it is performing bitwise AND operation. Now let us see what is the output of print A pipeline symbol B, or is represented as pipeline symbol. So when I do that, the last bit is 1, 0. When one of the input is 1, output will be 1. So I'm getting here 1. And in the second bit, we have 0, 1. When I perform logical OR, again the output is 1. Sorry, not logical OR, bitwise OR. And then in the third bit, we have 1, 1. So the bitwise operation between these two is 1. So this is binary, 111 is the answer. The decimal equivalent of this value is now 7. So the line number 15, print A or B is going to print the answer as 7. So now let us see the third operation. It is XOR. Bitwise XOR operation will be represented by means of caret symbol. So we have A, caret B, and we are printing the answer. So in case of XOR operation, when both the inputs are same, the answer will be 0. When they are different, answer will be 1. So now let us see what is the output of this XOR. So one of the input is 1, other is 0. So the values are different. So we will be getting the answer as 1. In the second bit, we have 0 and 1. And again, the values are different. So the second bit is now 1. In the third bit, we have 1 and 1 as the input. When the values are same, we'll be getting 0 at the output. So now we have the output as 0, 1, 1. The binary value is 0. The corresponding decimal value is now 3. So the output is now printed as 3. So now we have seen the basic bitwise operations. Now let us see the fourth bitwise operation, which is the bitwise complement. So here the bitwise not symbol is nothing but it is tilde symbol. So now let us see that with an example. So what is bitwise not? In case of bitwise not, first whatever is the data that will be represented in the binary, and we have to complement the data. If the original data is 1, we have to change it to 0. And if the original bit is 0, we'll be changing that to 1. That is called as bitwise not. So here I am now printing the bitwise not of A. When I print the answer, I am getting -6 as the output. My A is 5, but why I am getting -6? What it is doing internally. So now let us understand that with an example. So here in Python, whenever we do bitwise not operation, it is going to perform operation like this. If A is our data, when I do bitwise not of A, it is going to give us the answer as -A minus 1. So here A is 5. So minus A minus 1 is nothing but -5 minus 1, it is -6. So that will be printed as the answer. Suppose if my input is 55126, for that if I do the bitwise not operation, it will be doing minus this particular value, that is 55126 minus 1. So that's nothing but -55127. So that will be printed as the output. Here it is shown. And suppose if my input is bitwise not of -55126. So what is done internally? A is -55126. It is going to give -A minus 1. That is nothing but minus of -55126 minus 1. So this is now minus into minus is plus. So 55126 minus 1, it is 55125. So it will be printing the answer as 55125. Now let us understand how we are getting this particular answer. And what is the connection between 5 and the bitwise not of 5 as -6. For that, first let us write 5 in binary format. So here I am going to write it by using 8 bits. So 5 is represented as 101. When I write in 8 bits, I am going to fill the remaining leading 5 bits as zeros. What is the output of bitwise not of 5? So here our data is 5. So we want the output of bitwise not of 5. So it's nothing but we are going to complement each and every bit in this number. So this is our data, complement each and every bit. So first 4 bits are 0. When I complement, first 4 bits will be 1. And fifth bit is 0. So I'm going to complement this. I'm getting 1 now. And sixth bit is 1. When I complement, it is 0. Seventh bit is 0. When I complement, it is 1. And the last bit is 1. When I complement, it is 0. So now this is a complement of 5. So what is this value? So this is actually printed by this particular function, print bitwise not of A. So this value should be printed by the function. But we are getting at the output -6. So why we are getting -6? So what is the relation between this 5 and -6? So here, what is this -6? It is a negative number. In case of computers, we are going to store negative numbers by means of 2's complement representation of the corresponding positive values. So for example, how -6 is stored in the system is, we have to see what is the corresponding positive value. It is +6. We have to take the 2's complement of +6 and that answer will be stored. And how to find the 2's complement? It's nothing but find the 1's complement and then add 1 to that. So now let us evaluate the 2's complement of -6. So here I have to take the positive number because I want to find the representation of the negative number. Let me take the positive number of this, that is +6. Write 6 in the binary format. By using 8 bits, I am writing. So 6 is nothing but 110. Only 3 digits are there. So the remaining 5 bits I am filling with zeros. The leading 5 bits I am going to fill with 0. So this is a representation of 6. Now for -6, it will be first performing 1's complement of 6 and then adding 1 to that. So let's take the 1's complement of 6. So the first 5 bits are 0. So they will be changed to 1. And next 2 bits are 1. They will be changed to 0. And the last bit is 0. It will be changed to 1. Just toggle the bits. Now this is the 1's complement of 6. Now we have to add 1 to 1's complement to get the 2's complement. When I add 1 to that, 1 plus 1 is 0 and we will get the carry. So that carry is printed in the second bit. And remaining 0, 1, I'm simply copying the bits down. So now this is a 2's complement of 6. It's nothing but it is the answer of minus 6. So minus 6 is represented as 2's complement of plus 6. Now let us compare this value, which is in line number 20, with the value of this, which is in the line number 8. If you compare these two, you can see that both are same. So when I find bitwise not of A, that is nothing but bitwise not of 5, will be expecting the answer as minus 6. And this is the internal representation of minus 6. Because of that only, we are getting minus 6 at the output. So now this is how the bitwise not operator is going to work in Python. I think it is clear. Now let us understand the next two bitwise operators, which are nothing but shift operators. So in case of shift operator, we have two different shifting. One is shifting in the right direction and the other is shifting in the left direction. So the shift operator is represented by two operands. The first operand is going to tell what data you are going to shift. And the second operand is going to tell how many bit position you are going to shift. That is nothing but how many times you are going to shift the data. I am giving now a double greater than symbol 2. It means that you see the direction of the arrow, it is in the right direction. So I am going to shift the data A in the right direction by 2 times. So now let us see what is our A. It is 5. So I am writing 5 in the binary format 101. First, let us shift by 1 time. So I am going to shift it in the right direction. Every bit will move to the right by 1 bit position. So this one will be shifted to the right. So it will come and occupy this position. And this 0 will be shifted to the right. It will come and occupy this bit position. And this one will be lost. And what will happen to the third bit position? Here, always 0 will be appended. So we have now the data as 0, 1, 0. So now I have shifted only 1 time. I have to shift 1 more time because here it is A, right shift 2 times. So let me shift this particular data 1 more time in the right direction. So first, this 0 will be going to the next bit position. That is, it will come here. So we have the 0, which is coming here. And then this 1 will go to the next bit position in the right. So 1 is appearing here. So what will happen to this position? It will be inserting with 0. So we have now the value as 001. So which is the equivalent of 1. So when I print this particular data, I am getting the output as 1. And always remember, right shift is going to divide the number by 2. So here, my original input is 5. I have to divide this number by 2 times because here I have 2. So when I divide 5 by 2 for the first time, I'll be getting the answer as 2. So here we have to take integer division, truncate the fractional part. So when I divide 2 for the second time by 2, I'll be getting the answer as 1. That's why we are getting 1 as the answer. But this is how internally shifting will be done. This is an easy way to write the answer. Whenever we perform divide or whenever we perform right shift, 1 time it is going to divide the number by 2. And why it is 2 is we are doing binary manipulation. So the base for binary is 2. That's why every shift operation will be dividing the number by 2. Now let us see what is going to happen in the left shift. In case of the left shift, again it is going to accept 2 input. One is the number to be shifted and the second, how many times it is going to be shifted in the left direction. And the 2 less than symbol is going to indicate that it is a left shift operation. So now I am shifting A in the left direction 2 times. So now A is 101. When I shift it in the left direction 1 time, every bit will be shifted 1 position to the left. So this one is shifted 1 position to the left. So it is coming here. and this 0 is shifted one position to the left. Similarly, this one is shifted one position to the left. Now, as a new value, the 0 will be inserted. Because this 1 is shifted here, that position is now empty, so 0 will be inserted. So we have done shift one time. We have to again shift one more time because here we are doing a left shift 2. So when I shift one more time, I'll be getting the answer like this. So 1 will be shifted to the left, 0 will be shifted to the left, again 1 will be shifted to the left, 0 will be shifted to the left, and new data is 0 that is appended at the end. So now this is our final answer. That's nothing but the decimal equivalent is 20. And we can easily understand that left shift is going to multiply the number by 2 for every shift. So our initial value of A is 5. We are shifting this in the left direction 2 times. That means you have to multiply 5 by 2 2 times. When I multiply by 5 by 2 for the first time, I'll be getting the answer as 10. Then multiply 10 by 2 for the second time, you will be getting the answer as 20. So that is the answer we are getting. And this is how internally the shift is done. So I think bitwise operators are clear. Now let us focus on the special operators that are added in Python. They are not available in languages like C or C++. One category is membership operators. And membership operators are generally used to test whether a particular value or a variable is present in a collection or not. We have two membership operators. The first operator is in and the second operator is not in. So the in operator is going to check whether a value is present in the collection. If it is present in the collection, it is going to return true. If it is not present in the collection, it will return false. And not in is just the reverse of this. It is going to check whether a particular value is present in the collection or not. If it is not in the collection, then this condition is true. So it is going to return true. Otherwise, it will be returning false. Now let us see one example. So first I'm initializing A as 10, B as 50. Then I am creating one list which is initialized with square bracket. Always list will have square bracket and all the elements will be written inside the square bracket. So this list is having totally 5 elements. And I have one dictionary, and this dictionary is having 2 elements. The first element is 1 colon A. Remember that in case of a dictionary, we will have key value pair. So first is the key, 1 is the key, then we have colon, then A is the corresponding value. And then the second element in the dictionary is 2 colon B. So 2 is the key, followed by colon, followed by corresponding value. Now I am going to check whether A is present in the list or not. So I am checking A in list. If A is present in the list, it is going to return true. So what is A? It is 10. Check whether 10 is present in the list or not. Yes, it is present as a first element. Since A is in the list, this will be returning the answer as true. So when I print, I am getting the answer as true. And in the second print statement, I am checking whether B is not in the list. Okay, B is 50. Is 50 in the list? Yes, it is there. But I am checking B not in the list. So B not in the list is false because B is in the list. So we will be getting the answer as false. So here I am checking for not in. If it is not in, it is going to return me true, but it is in the list. So I am getting the answer as false. Next, we will check with the help of a string. I'm initializing S as Python programming. So S is nothing but now string data type. And I'm going to check whether a particular string Python is present in S or not. So I'm using in operator. So Python is now present in the string because this is here. So this is true. So true is now printed. And in the line number 11, I am checking again Python in S, but in this case, Python P is small p. Whereas in my original string, capital P is present. That means that this particular string is not present in the list because Python is case sensitive language. Okay, so only capital P Python is present, but here we have small p. Therefore, this is not in the list. I'm checking whether it is in the list. So it is false. So the answer is now printed as false. Now we will see how this operator is going to work for dictionary. So in case of dictionary, remember this operator will check only for the key, not for the value. Okay, a dictionary is going to contain two items. One is the key, another is the value. In operator is going to compare only with the key, not with the value. So first I am checking whether one in dict. So here in dict, check whether one is present in the key field. Yes, it is present in the key field. Therefore, this is going to return me true. So true is printed. Next, I am checking A in dict. You can see here, this is our dictionary. A is there in the dictionary, but where it is there? In the first element, A is present in the value part only. Always in operator is going to check whether this particular data is present in the key field. But here it is present in the value field. Therefore, it is not going to check for that. It will find only in the key field. So when I check for A in the key field, it is not there. So it is going to return false as the answer. So this is how the in and then not in membership operators are going to work in Python.